Hello there, welcome to my channel on chemistry lessons. This is BTEC Applied Science and it's Unit 5 Chemistry, and we're going to be looking at the June 2017 exam paper. And here it is there. So it's one of the very first ones, this. Okay, it was 2.5 hours, but that did include section A, which is biology, and section C, which is physics. First up though, if you don't subscribe, please do. Your support is very much appreciated, and please take advantage of the likes and comments features. So here we have the first question, and it does say question 6, but that's because questions 1 to 5 would have been section A, which were biology. Now, if you haven't watched my videos that cover the content, I do have 38 video playlists there on my channel, and you'll find a link at the top here. So I do suggest you watch those first. And when you're ready, you can come back to the question papers, pause the video at each question, have a go yourself, and then when you want to hear me going through the answers, you unpause the video. Simples. Okay, so some factories produce effluent containing hydrochloric acid. Full stop. Calcium hydroxide can be used to treat the effluent. Yes, it can. I remember revising this. And what does it do? It neutralizes it. There's a chemical reaction. Oh, there we go. Name the type of reaction. Neutralization. Neutralization, reaction between an acid and a base. So calcium hydroxide is used to neutralize acidic effluent. Write a balanced equation. Ooh, spicy. Right, calcium hydroxide. Calcium is in group 2, so it'll be 2 plus. Hydroxide is OH minus. So calcium hydroxide looks like this. We need 2 hydroxides, we put them in brackets. That's calcium hydroxide. Hydrochloric acid is HCl. The products are going to be salt and water. In this case, the salt will be calcium chloride. But again, I've got to be switched on because chloride is only minus because it's in group 7. I've already pointed out that calcium is 2 plus. So calcium chloride is CaCl2 plus water, H2O. Is it balanced? No, it's not. I need to put 2 here, and that balances it. 3 marks for that. Okay, so it's not a straightforward equation, that one, but there we go. If you've seen my videos, there was plenty of practice on there for you. Next question then, question number 7. As always, pause the video, have a go. When you want to hear me going through the answers, we unpause the video. Which of these is a free radical? Right, well, when we've done this, a free radical we represent with a dot to show an unpaired electron. This is the only one that has that dot, that unpaired electron. There's the dot, look, that's what I was looking for. Which of these is an electrophile? Oh, okay, well, electrophiles will accept a pair of electrons and are usually positive or delta positive. So what's screaming here is this positive here. That's going to be my electrophile. Next up, the mechanism. So this here is bromine, which is a halogen, with ethene, and it's the electrophilic addition. Yes, it is. We practiced this. You'll see it in my video. So ethene looks like this. I'm going to show the reaction with bromine, if you know what I mean, bro. Put it there. What happens is I'm going to change the colour just to show the curly arrows. The pi electrons attack this bromine. This bromine was actually delta plus, and this bromine was delta minus. That pi bond induced that dipole. That bond did this. Then what was I left with? Well, the bromine has then bonded to one of the carbons. I don't need to worry about carbocation stability here because it's symmetrical. So I have my carbocation and my bromine that didn't bond was left with a lone pair. And then it did this. Whee. And then I'll draw my final product, which is 1,2-dibromoethane. If it's annoying you that I've drawn them up the top, it's actually annoyed me now that I'm looking at it, but it doesn't matter as long as the bromine are on there's one bromine on either carbon, I can draw them on the top or the bottom or the left or the right. It doesn't matter. There's the mark scheme, look. That's where my 4 marks come from. So correct partial charges on the bromine. Yes, I did. That was right there and there. Look, my delta plus, delta minus. A curly arrow from the bromine bond to the Br. Yes, I've done that. That's my second mark. Carbocation. Yes, I've done that. And a curly arrow from the Br minus to the C plus. I've done that. There's my 4 marks. Question 8. As always, pause the video, and when we're ready to hear the answers, unpause. Alkanes are a group of organic compounds that have the general formula CnH2n plus 2. Give the molecular formula of an alkane that has 12 carbons. So it's C12H. 2 times 12 is 24. 24 plus 2 is 26. 1 mark. Next up, I've been asked to draw the 3D representation of methane. Now, reminder of my videos, we looked at the bond angles and 3D representations for alkanes, alkenes and benzene. So here it wants me to draw the tetrahedral shape of the methane. I draw 2 lines and then I have to draw a wedge and I have to draw a dash. As long as I've drawn 1 dash, 1 wedge and 2 lines, I can put them in any order. I'm going to get my mark there. Okay, next up. Again, as always, pause your video when you want to see me go through them. Unpause the video. So here I've got some alkanes and their boiling points. The boiling points increases with chain length. So that's actually what my trend is. So the boiling point increases with chain length, and that's because the molecular mass increases and the van der Waals forces of attraction will increase, which means more energy is needed to break the bonds. So to summarize, as bond length increases, boiling point increases because the molecular mass increases and the van der Waals forces of attraction become stronger. More energy is needed to break them. Next up, I've been asked to complete the diagram by drawing the pi bond and the sigma bond. Okie dokie. Well, the sigma bond I'm just going to draw directly between. There we go. Just draw some electron cloud there. That's my sigma bond. And the pi bond we have above and below. And there'll be a pair of electrons here. So I'm going to label that the pi bond. So what the examiner is looking for is that I've done my sigma bond between the 2 carbon atoms and I've done my pi bond above and below. Next up then, 3 marks. As always, pause the video when you want to hear the answers, unpause. Right, butene is an alkene. I'm just going to remind myself what butene looks like. 1, 2, 3, 4, with a double bond between the second and the third. The rest will all be hydrogens. Don't put too many hydrogens on the second and third carbon because it can only have 4 bonds. Right, okay, and it wants me to do the cis and the trans. Right, cis is when the identical groups are going to be on the same side. In this case, it's CH3 and H and H. That would be classed as the cis isomer. To do the trans, I'm simply going to switch one of the sides over. So I'm going to leave the left-hand side the same, and I'm going to choose to put the CH3 at the bottom now. So that would be classed as the trans, because the same group are on opposite sides of the double bond. That's my cis and trans isomers there, worth 3 marks. Over to question 9. You know the drill by now. Okay, so a lot of information here. Hess cycle. I'm betting I'm going to have to do a calculation at some point. But all I'm actually asked to do here is to define the standard enthalpy of formation. Okay, so that's the enthalpy change when 1 mole of a substance is formed from its elements in their standard states under standard conditions. Now, don't panic if yours isn't word for word identical to mine, because there's more than one correct way of defining this. The key points are that it's an enthalpy change. It's 1 mole of a substance that's being formed under standard conditions from elements. So, you know, there's more than one correct way there. So don't panic if yours is worded slightly different. Right. As expected, there was a calculation coming up. So there's one, every paper I've ever seen, there's one of these types of calculations. So it's worth making sure you understand what's going on. So have a go at this yourself. Unpause when you're ready to see me go through this. Right, so what I've got to look at first is what I've been given. So I've got to look at this table here. I've been given combustion, because students always ask me, how do I know which way to point the arrows? Okay, because I always talk about making this triangle. Now I've been asked to find this top value here. This is what I don't know. This is the one I've been asked. This is my X, this is my unknown. I have been given the combustion, and I've been given the combustion of methane. I'm going to go to this one first. That's this arrow here, look, that's burning methane. If you're burning methane, you're reacting it. It's a reactant, you're going away from it. So this arrow points down here. And this arrow is minus 890.3. The other two values I've been given are the combustion of carbon, which would be burning carbon to turn it into carbon dioxide. And that's minus 393.7. Next up, I've been given the combustion of hydrogen. Now, if you burn hydrogen, you turn it into water, you react it with oxygen. So that goes down here, look. But this time, it's 2 moles of hydrogen. So I need to take 2 times minus 285.8. So I'm going to take my calculator and work that out. 2 times 285.8 is equal to 571.6. Now what I need to do is tidy up this section here, because this is quite messy here. There's 2 arrows here. So when I come back to my triangle on this side, I only want 1 arrow. So I'm combining those 2 arrows. So it's 571.6 and 393.7. So if I combine those 2 arrows, I end up with minus 965.3. So all I've done is combine those 2 arrows into 1. Now I can apply Hess's law. I've got my start and my finish point here. My root 1 is X. And my root 2, I'll change colour, is down here, up here. So for the first leg of the journey, I'm going in the same direction as this arrow. So this is minus 965.3. However, in this second leg of the journey from the bottom back up, I'm going in the opposite direction to this arrow. This arrow points down and I'm going against it. So I have to change the sign here to plus. And what do I get here on my calculator? I get minus 75 kilojoules per mole. 4 marks. And as I've said, there's one of those on every paper I've seen. Sometimes it's formation value, sometimes it's combustion value. So you've got to look at this table to decide whether your arrows are pointing down here or up. Today they were pointing down because I was given combustion. I was reacting these things away from them. I was burning them. If I was given formation values, I'd be making them, I'd be pointing towards them. Moving on then. So have a go at this one, pause the video. When you're ready to see the answer, unpause. Again, another very, very common question. I think I've seen one of these every paper as well. So again, it's worth recognizing the types of questions that we've got going on here. So this is a Q equals MC delta T question. My M is the mass of the water. That's 5 kilograms. Has to be in grams. So be careful. When I do this calculation, it's the mass of water in grams. Specific heat capacity, 4.18. And my delta T, what's happened? It's gone from 296 to 308. So it's gone up by 12 times by 12. Right, calculator time. 5,000 times 4.18 times by 12 equals 2,50800. But again, I've been trained that that's in joules. Look, they want the answer in kilojoules. So don't they've done this a couple of times now. It's quite common for them to do this. So I need to divide my joules by 1,000. And my final answer is 250.8 kilojoules. Moving on to question 10. So 4 marks here. Pause the video when we're ready to see the answers. We can unpause. Alumina is a material that's commonly used in the lining of furnaces. Give 2 properties, right? Okay, well, the reason it's used in furnaces is because it's unreactive, which is good, which means it doesn't react in the furnace. So it's unreactive, and it has a very high melting point, which means it remains a solid. It doesn't melt. There's my 2 reasons. Aluminium can be extracted from alumina by electrolysis. The alumina is dissolved in molten chrolite to form a solution. Yes, it is. And explain why it must be dissolved before electrolysis can take place. Well, if the alumina is solid, the ions can't move. If it's dissolved, the ions can move. So ions can move and carry electric charge or electric current in electrolysis, because electrolysis will only work if we've got mobile ions to carry the charge. Next 2 marks. 2 reasons why the electrolysis of alumina is expensive. Well, first of all, you've got to heat it up to a high temperature, so lots of energy required. So lots of energy is required to heat, and lots of electricity is required. My writing's awful on this, isn't it? I'll take my time. Lots of electricity is required, and also the graphite anode needs replacing over time, because we know that the oxygen formed at the anode corrodes the graphite anode, and over time you need to replace that. I only need to say 2 of those things. I've said 3 things, so any 2 of those are absolutely fine. And now we have the last question. The last question is always a 6 marker, so be prepared for this, okay? Now my advice on these 6 markers, as always, is rather than seeing it as one big question, break it down into 2 or 3 smaller questions, okay? And make sure you answer all parts of it, okay? So if you can recognize that it's 2 different questions, don't just focus on one half. You've got to answer both halves. And it's not about writing a massive list of everything, okay? You don't have to make loads and loads. You don't have to fill the entire page, because you were given plenty of space to write here. So I do suggest you have a go at this first, and when you're ready to see my answer, we can unpause the video. Okay, so I've chosen to break this into 3 sections. I've got to talk about how sodium hydroxide is formed. I've got to talk about how chlorine is formed, and I need to talk about hydrogen. So my first point is to point out that brine is in fact sodium chloride solution. This means that sodium ions, chloride ions, hydrogen ions and hydroxide ions are all present in this solution, and they can move. So what's going to happen is, at the positive electrode, which is the anode, chloride ions will be attracted to it and form chlorine gas. Now, this half equation looked like this, if we remember. So I'm going to put a sentence above. I am going to open up by telling the examiner that brine contains these 4 ions. I'm then going to put a sentence above this and say chloride ions will be attracted to the anode, and chloride ions will become chlorine gas by losing electrons. And I can give this equation. So I've already answered how chlorine is formed. Now what I need to do is, I'm going to talk about the hydrogen. So I'm going to say that hydrogen ions will be attracted to the negative electrode, where it will become hydrogen gas. In doing so, make sure it's balanced. This was the half equation. So hydrogen gas is going to be formed at the negative electrode. And finally, I will then say this leaves behind sodium ions and hydroxide ions, because the chloride has gone to the positive electrode, the hydrogen have gone to the negative electrode, so the electrolyte left behind, so NaOH is left behind in the electrolyte. And what I'll do is I'll put the mark scheme on now so you can see there's a massive list on the mark scheme, and as I've kind of said originally, you do not have to write or get every single point. You basically need to make sure that you've answered the 3 parts to the question. You can see there, I'm not going to go through every single step. You can pause the video and have a look, but as long as I've made enough points, I made at least 2 points about each one. I made at least 2 points about how chlorine was made. I made at least 2 points about how hydrogen was made, and I explained that the sodium ions and the hydroxide ions were left behind, leaving sodium hydroxide solution. That is enough for 6 marks. You do not need to hit everything on this list. So look forward to the 6 markers, because they are a good opportunity of picking up all 6 marks. And that's the end of that paper then. So hope that was useful, and good luck with the revision and good luck with your exams.